Hello everyone, my name is Akanksha and today we are going to talk about a topic pipes and kiston. But before going into the topic, I would highly recommend you to go through the topic work done before, because if you go through the work done before going into this topic, it will be very easy for you to understand, because both these topics are I would say connected. And about myself, my name is Akanksha. I'm an assistant professor in the Department of Mathematics at Manipal Institute of Technology. So let's get started. This in this lecture, we are going to first talk about basic concepts which you may be needing while solving the problems, and then we move forwards to the problem. So this is a very basic topic, and when you solve the problems, you will be able to connect to them. Okay, so let's get started. So these are some basic theory and the terminology we may be using while solving the problem. So first terminology is work rate. So what is mean by rate? So here consider this scenario. If a pipe, so pipe and kiston. So in this topic, all your problem will be around pipes, tanks, and there is a pipe which can fill the tank in these many hours, these kind of problems. So problems will be very easy to understand, very practical problems. So once you understand the problem, it will be very easy for you to solve also. So let's get started. First topic, first terminology I would say is work done. So let's see what is mean by work done or work rate. So if a pipe can fill a tank in X hours. Okay, so there is a pipe, there is a tank. If a pipe can fill a tank in X hours, then in 1 hour it fills 1 by X of the tank, right? And this 1 by X is known as, this is its filling rate. Okay, so now just try to understand this problem. So just try to understand this line, what they are trying to say. So you have a, so there is a tank. Okay, you have a tank, here is a pipe, and it is given that this pipe can fill this tank in 5 hours. Well, suppose in 5 hours or X hours. So you know that in 1 hour how much tank will be filled. It is common sense. So this full tank is filled in X hour. So in 1 hour, you can fill only 1x of the tank. This 1 by x is known as filling rate. Okay. So filling rate of the pipe is 1 upon x. Similarly, if a pipe can empty a tank in y hours. Now suppose the same tank, here you have a pipe which can empty the tank. So, if a pipe can empty a tank in y hours, then in 1 hour it empties 1 by x of the tank. Similar logic. This is its emptying rate. So, emptying rate of the pipe is 1 upon y. Okay. So, rate means work done in 1 hour. So if time is given, rate will be 1 upon the time. Or if rate is given, time is 1 upon the rate. So rate is equal to 1 upon time, and similarly time is equal to 1 upon rate. This you please remember. Okay. So now let us consider one example. A pipe fills a tank in 5 hours, right? In 1 hour. So now filling rate of the pipe would be, so just read this line. A pipe fills a tank in 5 hours. Can you tell me filling rate of the pipe? Filling rate of the pipe will be 1 upon 5. Okay, that is how you can compute rate, filling rate or emptying rate. In 1 hour, it fills 1 upon 5 of the tank. That is the rate. Similarly, another pipe empties the tank in 10 hours. In 1 hour, it empties 1 upon 10 of the tank. So from this pipe is for filling the tank. This another pipe is for emptying the tank. So emptying rate of the pipe is 1 upon the total time. So it is 1 upon 10 because in 10 hour it can empty the tank. So rate would be emptying rate would be 1 upon time is 1 upon 10. Next, combined work means if there are more than one pipe which is used to fill the tank, then what will happen? So combined work means filling the tank. So if pipe A fills a tank in X hours and pipe B fills it in Y hours. Okay, so there is one single tank. Okay, there is a tank. Let me draw it again. And two pipes are used, maybe the pipe A and pipe B, to fill the tank. Okay, what is given? If pipe A fills the tank in X hour and pipe B fills the tank in Y hours, so from these line you can see that filling rate of pipe A is 1 upon X, right? Similarly, filling rate of pipe B is 1 upon Y, right? Now, then together in 1 hour they fill 1 upon X plus 1 upon Y of the tank. Makes sense, no? So, one pipe in 1 hour can fill 1 upon X of the tank. Similarly, pipe B can fill 1 upon Y in 1 hour. So, if both pipe are open together, so in 1 hour they can fill 1 upon X plus 1 upon Y of the tank. So, combined filling rate will be, right? So, combined filling rate will be 1 upon X plus 1 upon Y. So, single filling rate was 1 upon X and 1 upon Y. If they are working together, then combined or effective filling rate is 1 upon X plus 1 upon Y. Now, this is the rate. How much time they will take? So, next is total time. The total time taken to fill the tank when both are open is 1 upon the rate. That means 1 upon combined rate. Combined rate is 1 upon X plus 1 upon Y. Right? So this you have to solve, and once you solve it, you will get this X into Y upon X plus Y. So total time is 1 upon rate, and similarly rate is 1 upon time. So here you can see that it was written if pipe A fills the tank in X hour, that means rate of pipe A is 1 upon X. Similarly, pipe B fills it in Y hours. So filling rate of pipe B was 1 upon Y. So combined rate, add them up, and total time taken when both pipes were open is 1 upon the total combined rate. This is the time. Time taken in filling the tank when both pipe A and pipe B were used. Now let's look at one example. Pipe A fills in 4 hours. Pipe B can fill a tank in 6 hours. Okay. So pipe A can fill the tank in 4 hours. Pipe B can fill the tank in 6 hours. So what would be the combined rate? Combined filling rate will be 1 upon 5 because 1 upon 4 because 4 hours pipe A takes to fill the tank. So filling rate of pipe A is 1 upon 4 plus filling rate of pipe B is 1 upon 6. So combined rate is 1 upon 4 plus 1 upon 6. Now take LCM 4 and 6. So 2, it will be 2 and 3. Again you can take 2, 3 as it is, then 3, 1 and 1. So LCM will be 2 into 2 into 3. That is 12. So LCM is 12. 4 3s are 12 plus 6 2s are 12. So it is 5 upon 12. That is the combined rate. Now total time taken, total time these both pipe will take in filling the tank will be inverse of the rate, means 1 upon rate. 1 upon 5 upon 12. So that is 12 upon 5. Now if you do the division, this you'll see that it will come out to be 2.5 hours. So that is what is written. So combined rate is 5 upon 12. Total time is 12 upon 5. 1 upon the rate. That is how we will solve the problems. Next, combined work in both filling and emptying. What does it mean? Suppose again there are two pipes. Okay, one pipe you are using to fill the tank and other pipe you are using to emptying the tank. Okay, so now what would be the combined work? Either it could be filling the tank, it could be emptying the tank. Let's see the scenario. So if pipe A fills a tank in X hours. Okay, so rate of filling for pipe A is 1 upon X. You got it? Similarly, and pipe B empties it in Y hours. So what information is given? Filling rate of pipe A is 1 upon X. Similarly, emptying rate of pipe B is 1 upon Y. Okay. Now, combined rate would be, now you tell me combined rate would be. So now first thing you have to see, combined rate of what? Filling the tank or emptying the tank. So here you can see that one pipe is used to fill the tank, one pipe is used to emptying the tank. So whatever be the reason, so net amount fill in 1 hour would be 1 upon x minus 1 upon y. So you have to subtract the emptying rate from the filling rate if you want to fill the pipe, if you want to know filling rate. So combined filling rate will be 1 upon x minus 1 upon y, because only this quantity is contributing in filling the tank and this one is emptying the tank, so you have to subtract it. So when both pipe were used to filling the tank, that time we were adding the filling rate, but here two pipes are doing completely different, opposite of each other's work. So one pipe is filling the tank, other pipe is emptying the tank. So you have to subtract one from the other. Now, how will you get to know कि eventually your tank will be filled or your tank will be empty? So that depend on which pipe is doing its work more fast, right? Which one is doing for the work faster? So if 1 upon x, that is the rate of filling the tank, if the rate of filling the tank is more than rate of emptying the tank, so eventually your tank will be filled. You got it? If the pipe you are using to filling the tank is more powerful than the pipe you are using to empty the tank, so eventually you will see that your tank is filled. And how much time it will take to fill the tank completely? It is 1 upon the effective rate. Effective rate is 1 upon x minus 1 upon y. So total time will be 1 upon the rate. Similarly, if the pipe you are using to emptying the tank is more powerful than filling the tank, you will see that eventually your tank will be empty. Okay, and rate, so combined emptying rate will be, because here we want to empty the tank, will be 1 upon y minus 1 upon x, because y is doing the work in the favor of what we want eventually, and x is doing the work in opposite direction in this case. So rate will be 1 upon y minus 1 upon x. So time will be, so total time taken to empty the tank is 1 upon the rate. So that is the rule. So if time is given, you can compute the rate. If rate you know, you can compute the time. Is that okay? So there are two type of combined work. Two pipes are used to fill the tank, or one pipe is used to fill the tank, another pipe is used to emptying the tank. So now let's look at one example. So A fills in 3 hours. So there is a pipe. Pipe A fills the tank in 3 hours. Pipe B can empty the tank in 6 hours. So consider a tank. Here is your pipe A. And let's say here you have a pipe B which can empty the tank. So pipe A can fill the tank in 3 hours. What would be the filling rate? Filling rate will be 1 upon 3, right? Because time taken in filling the tank is 3 hours. So rate will be 1 upon 3. Similarly, emptying rate will be how much time pipe B takes to empty the tank? It is 6 hours. So emptying rate will be 1 upon 6. Now you tell me which one is more? 1 upon 3 is more, no? So filling rate is greater than emptying rate. So eventually, so that means your this A pipe is more powerful than pipe B. So eventually your tank will be filled, right? So in that case, combined filling rate will be 1 upon 3 minus 1 upon 6. Now time taken, so this you compute first is 6, 2 minus 1 is 1 upon 6. So time taken in filling the tank is 1 upon 1 upon 6. That is 1 upon the rate. It is 6 hours. That is what is written over here. Is that okay? Now, there you may see one more terminology while solving the problem. That is leakage. Okay. So till now we have just used pipes. But in the tank, you may find in the problems that there is a leakage. So what will happen to that? So leakage. A leak acts as an emptying pipe because leak is also contribute to empty the pipe, empty the tank, right? So its rate is subtracted from the filling rate of other pipes. So let's see one example. A pipe fills in 2 hours. Okay, so there is a pipe which can fill the tank in 2 hours. So let's say you have a big tank. In 2 hours, it can fill the tank, but there is a leakage. Let's say here the tank has a leakage which can empty the tank in 6 hours. Okay, so now net rate means combined rate would be so rate filling rate is again same type of problem. Filling rate is 1 upon 2. Emptying rate here is due to leakage, not due to another pipe. But anyway, it is emptying. So that is why I'm using emptying rate is 1 upon 6 because it will take 6 hours to empty the tank. So rate will be 1 upon 6. Now combined filling rate is 1 upon 2 minus 1 upon 6. Now again you have to take the LCM. LCM is 6. 2 3s are 6. Sorry. So it will be 3 minus 1. So 2 upon 6. 2 upon 6 is same as 1 upon 3. So time taken in filling the tank is 1 upon 1 upon 3. That is 3 hours. That is what is written over here. So now just look at this problem. A pipe fills in 2 hours. A leak empties in 6 hours. So net rate is 1 upon 2 minus 1 upon 6. That is 1 upon 3 of the tank per hour. So that is the rate. So how much time it will take to fill the tank? 1 upon 1 upon 3. That is 1 upon the rate. And that is 3 hours. Now we'll look at some problems. So all problem will be around these concepts only. Terminology, everything would be the same. So let's look at this problem. So first you try to understand the problem and then you have to think how to proceed. What is given, what they are asking you to do. Okay, what is the question? So basically, first thing you have to understand that thoroughly. So a pipe can fill a tank in 6 hours. Okay, so there is a pipe which can fill the tank in 6 hours. Another pipe can fill the same tank in 8 hours. Okay, so there are two pipes, one can fill in 6 hours, other can fill in 8 hours. So you can compute the rate, filling rate for both the pipe. Got it? Now, if both pipes are opened together, okay, how long will it take to fill the tank? So basically, you have to compute the time taken in filling the tank when both pipes are opened. So to compute the time, what you need to know? You need to know the effective rate. So you need to know effective filling rate or combined filling rate. How do we get to know combined filling rate? You know the filling rate for individual. Just add them up. Okay, so let's get started. Filling rate of first pipe. What would be the filling rate for first pipe? It takes 6 hours. So rate will be 1 upon 6. Now second pipe. Filling rate of second pipe. What is the filling rate? What would be the filling rate for second pipe? So second pipe takes 8 hours to fill the tank. So it would be 1 upon 8. Now effective or combined. Combined filling rate would be, add them up, 1 upon 6 plus 1 upon 8. Because if both are working together, it will take this much time, right? 1 upon 6 plus 1 upon 8. Take the LCM. So what would be the LCM? Let me take LCM. 6 and 8. Start with 2. It will be 3. It will be 4 and 3 be 1. It is 4 as it is. Then take 2, 1 and 2. Then take 2. It is 1 and 1. Then you have to stop. So LCM will be 2 into 3 into 2 into 2. So it is 24. So 2 into 3, 6. 6 into 2 is 12. 12 into 2 is 24. So LCM is 24. Now 6 4s are 24 plus 8 3s are 24. So it is 7 upon 24. This is the rate. Now total time taken is, rate is 7 upon 24 na, so time taken will be 24 upon 7. Now you have to solve it. You have to divide and see what will you get. So 24 ko you have to divide by 7. So 7 3s are 21, 3 and point, take 0, take 0 down, it is 4, 28, 2, and then you can keep on doing this, but you can see that this is the option, 3 hours 45 minutes. So 3.45 hours. Option B is correct. Is that okay? So filling rate of single pipe, filling rate of another pipe. So combined filling rate will be, add them up. Once you know the combined filling rate, time taken by uh, time taken total time taken in filling the tank is 1 upon the rate. So 7 by 4, time will be 24 by 7. And then you have to do the division. And you can see that whichever is the closest option, that will be your final answer. Next problem. Orchestra has two pipes. One can fill it in one can fill it with water in 8 hours and other can empty it in 12 hours. So here you have a tank, again combined work, but one pipe is filling the tank, another pipe is emptying the tank. Now let's see what they are asking you to do. If both pipes are open, how long will it take to fill the crystal? So again, you have to compute the total time taken by both the pipe in filling the tank. So here, but pipe is doing one pipe is contributing in filling the tank, another pipe is contributing in emptying the tank. So one pipe is doing opposite of what you want, right? Basically, because ultimately you want to fill the piston. So let's start. Filling rate will be 8 hours one pipe will take to fill the tank. It is 1 upon 8. Then you have emptying rate also, because you have another pipe which is emptying your tank. Emptying rate is equal to 1 upon 12, right? Because another pipe will take 12 hours to empty the tank. So emptying rate will be 1 upon 12. Now combined rate or combined filling rate, I will write, will be 1 upon 8 minus 1 upon 12. Here you have to subtract, because 1 upon 8 is doing what you want ultimately, but this 1 upon 12 is doing the opposite of what you want, because ultimately we want to fill the tank, but 1 upon 12 is the rate to emptying the tank. So combined filling rate will be 1 upon 8 minus 1 upon 12. So this you have to solve, compute the LCM. So LCM, let's compute 8 and 12. 2 say I will start, it is 4, it is 6, again 2, it is 2, it is 3, again 2, it is 1, it is 3 as it is, then 3 I will take, it is 1 and 1. So LCM will be 2 into 2 into 2 into, sorry, 3. So it is 2 into 2, 4, 4 into 2, 8, 8 3s are 24. So it is 24. So 8 3s are 24, 3 minus 12 2s are 24. It is this. So it is 1 upon 24. So time taken will be in filling the tank will be, can you tell me? Rate is given, time will be 1 upon the rate. So 1 upon 24. It is 24 hours. So option A is correct. Is that okay? Again, combined work, but one pipe is doing the work opposite what you want. Opposite to the what you want. Next problem. Here you have 3 pipes. Okay. So what they are saying, just read the problem carefully and then you you start working on the problem because that is very important. Just don't jump into the solving. Okay, so what is given? 3 pipes A, B, and C can fill a tank in 6 hours. Okay, so if 3 pipes are working together, then it can fill the tank in 6 hours. So it is a bit different. So combined filling rate is given. After working at it together for 2 hours. Okay, so all 3 pipes are opened for 2 hours and then C is closed. So this is the scenario. Okay, let's read the problem further. C is closed and A and B can fill the remaining part in 7 hours. How long would C take to fill the tank alone? How long would C take to fill the tank alone? What they want to know. So they want to know pipe C, if it is working alone, how long would it take? Time you want to know. So, time, how would you get to know the time? If you get to know the rate, if somehow you get to know the filling rate of pipe C, you can compute the time, right? Because time is 1 upon rate. So, basically, we want to know the rate of filling rate of pipe C. So, till here, we have seen that key. It is given that pipe A can fill the tank in these many hours, pipe B can fill the tank in these many hours, and then we compute the combined rate by adding them up. Here, combined rate is given, and you are asked to compute individual rate. So it is a bit reverse of the problem which we were doing till now. So now we'll start. Suppose filling rates of pipe A, B, and C are RA, RB, and RC. Let's say filling rate is RA, RB, and RC. Now it is given that 3 pipes A, B, C can fill the tank in 6 hours. So combined rate is given in 6 hours. So RA plus RB plus RC combined rate is 1 upon 6. Right? This is your combined rate. It is given. But they are saying 2 hours these 3 pipes are working together. So we have to compute in 2 hours how much tank is filled. So that I will write as work done in 2 hours. Okay. Because for 2 hours, all 3 pipes were opened to fill the tank. So work done in 2 hours will be 2 into rate of the combined rate, right? So that is 1 upon 6. And that is equal to 2 upon 6 is 1 upon 3. So in 2 hours, 1 upon 1/3 of the tank is filled. So this much work has already been done. So in 2 hours, 1/3 of the tank is filled, right? How much is remaining? So remaining work is, how much is remaining? It is 1 minus 1 upon 3. right? Because 1/3 is already done. So how much will be remaining? 1 minus 1 upon 3, that is 2/3. 2/3 is remaining. And they are saying that this 2/3, this remaining work is done by pipe A and B only, because after 2 hours C is closed. So, and how much time they have taken A and B together? So they have taken 7 hours. So 7 into rate of A plus rate of B is equal to 2 upon 3, because that 2/3 work they have done, A and B pipe have done in 7 hours. So now you just have to substitute the value of RA plus RB. From where you can get this value? You know this equation? This was given. So from this equation, can I write RA plus RB is equal to 1 upon 6 minus RC? Both are equivalent because RA plus RB plus RC is 1 upon 6. So RA plus RB is equal to 1 upon 6 minus RC. So combined rate of A and B is 1 upon 6 minus rate of C. This value I am going to substitute over here. So 7 into 1 upon 6 minus RC is equal to 2 upon 3. Again, we have to do some simple manipulation. So 1 upon 6 minus RC is equal to 2 upon 3 into 7. So this 7 will go into the denominator and it is equal to 2 upon 21. Right? 2 upon 21. So it is RC. So ultimately, if you remember, we want to compute RC, rate of pipe, filling rate of pipe C. If you get to know filling rate of pipe C, you will get to know how long it will take to fill the pipe alone. So RC we have to compute. So from this equation, it will be 1 upon 6 minus 2 upon 21 is equal to RC. This we have to do. Now take the LCM 6 and 21. Let me take the LCM 6 and 21. 3 I will start with 2, 7, 2 will give 1, 7 as it is, 7, 1, 1. So LCM will be 3 into 2 into 7. It is 42. So 3 into 2 is 6 into 7 is 42. So LCM is 42. So RC is equal to 42. So 6 sevens are 42 and 22 into 2 is 42. So it is 4. So it is 3 upon 42. 3 upon 42 means 1 upon 14. So time taken, so this is the rate. This is the rate of filling rate of pipe C. Filling, so RC is equal to 1 upon 14. So time taken, so how much time it will take to fill the tank alone? Time taken by pipe C will be 1 upon the rate, that is 14 hours. So this is the correct option. So option C is correct. Is that okay? So see, a bit reverse question were asked. Combined rate was given and it is given that for 2 hours all 3 pipes were working together, but after 2 hours C is closed and A and B has filled the remaining part in 7 hours. How long would C take to fill the tank? So combined rate, so assume that the rate filling rate of pipe A, B, C is RA, RB and RC. So combined rate is 1 upon 6, right? Because altogether they are they are taking 6 hours. So rate will be 1 upon 6. So combined rate was 1 upon 6. So these 3 pipes were working together for 2 hours. So work done in 2 hours will be 2 into combined rate, right? That is 1 upon 3. So how much part is remaining? 1 minus 1 upon 3 part is remaining. So this remaining part A and B has done. So this remaining work A and B together has done in 7 hours. So 7 into rate of A, combined rate of A and B is equal to 2 upon 3. Now I have used this equation and substitute the value of RA and RB and get the value of RC. And once you know the rate, filling rate of C, you will get to know the time taken by C to fill the tank alone. It is 14 hours. Let's look at another problem. Pipe A can fill a tank in 15 hours. Okay. And pipe B can fill it in 20 hours. So two pipes are given. One can fill in 15 hours. Another can fill in 20 hours. So since time is given, you can compute the rate, right? Filling rate. Now, what next? It is given that both are opened together. Okay, but after 4 hours, A is closed. How much long will B take to fill the tank? There's a bit similar kind of problem what we have solved just now. So two pipes are there, both are used to fill the tank, but after 4 hours A is closed. So how much longer will B take to fill the tank? So let's get started. So filling rate of pipe A 1 upon 15, right? Because 15 hours it will take to fill the tank. So rate will be 1 upon 15. Similarly, filling rate of pipe B is equal to 1 upon 20. Again, similar logic because it will take 20 hours to fill the tank. So rate will be 1 upon 20. So now combined filling rate would be 1 upon 15 plus 1 upon 20. Now solve it, take LCM. So 15 and 20. Let me start with 5. So it is 3, it is 4, 3, 1, 4 as it is. I will take 2, it is 1, it is 2. Again, I will take 2, 1 and 1. So LCM will be 5 into 3 into 2 into 2. It is 60. Because 5 into 3 is 15. 15 into 2 is 30. 30 into 2 is 60. So 60 is the LCM. Now 15 fours are 60 plus 23 is 60. So it is 7 upon 60. So 7 upon 60 is combined filling rate. Why do we need it? Because for 4 hours both pipe were working together to fill the pipe, to fill the tank. So because we want to know how much tank is filled in 4 hours. So work done in 4 hours is equal to 4 into combined rate. So 4 into 7 upon 60. What will you get? So 4 is 60 if you, so you will get 15. So it is 7 upon 15. So this much work has already been done. 7 upon 15. What is remaining? Remaining work is equal to 1 upon 7 upon 15 because 7 upon 15 is already done. So what is remaining? 1 upon 7 upon 15. So again, if you take LCM and solve it, you will get 8 upon 15. So this much work is remaining. Means this much part of the tank is still is so this much part of the tank you have to fill. Now they are asking to fill 8 upon 15th of the tank, how much longer B will take because A is closed now. So to fill that tank, how much time to fill this much tank, how long pipe B will take. So you have to calculate the time. So suppose B, let me write pipe B. Suppose pipe B will take X hours to fill 8 upon 15 of the tank, means remaining of the tank. So X into rate of the filling rate of pipe B is equal to 8 upon 15 because that is what they are saying. So it will take X hours to fill the remaining part. Now you do the manipulation, you will get X is equal to 8 into 20 upon 15. You take this 22 on the numerator. And finally you will have, so this 3, 4, so it is 32. 32 by 3. Now you have to compute, you have to do this division. So 32, you have to divide by 3, 1, it is 3. Now you have to take 0, take this 2 down. So 10 point something will come. So option B is correct. Okay. So that is how you have to solve this type of problem. So this is a bit different from the previous one, but till here, both are the same. Next problem. A tap can fill a tank in 12 minutes and another can empty it in 20 minutes. Again, two taps or two pipes. One is filling the tank, another one is emptying the tank. If both are opened together, in how many minutes will the tank be full? So it is pretty simple. So one tap is used to fill the tank, another tap is used to empty the tank. So write down the rate. Filling rate is equal to 1 upon 12 because 12 minutes one tap will take to fill the tank. So filling rate will be 1 upon 12. And again, emptying rate. How much time the other tap will take to empty the tank? It is 20 minutes. So 1 upon 20. Now, effective filling rate is so because we are interested in filling the tank, so 1 upon 12, which is actually, this is the rate which is actually contributing in the work we are interested in, and minus 1 upon 20 because this is the rate which is doing the work in opposite direction, means opposite of the work which we are interested in. So that part we have to subtract. So this is the effective filling rate. Again, you have to take the LCM. So LCM we have to compute 12 and 20. I'll start with 2, 6, 10. Again 2, it will be 3, it will be 5. Then I will take 3, it is 1, 5 as it is. Then I will take 1, 1 and 1. So LCM will be 2 into 2 into 3 into 5. So 2 into 2, 4. 4 into 3, 12. 12 into 5 is 60, right? So 60 is the LCM. Now 12 5s are 60 minus 23s are 50. So it is 3. So ultimately it is 2 upon 60 or 1 upon 30, right? Both are equivalent. Now this is the effective filling rate. Now how much minute will it take to fill the tank completely? So rate is given, combined rate is given. How much time they will take? So time is equal to total time. Let me write. Total time is equal to 1 upon effective rate, and that is 30. 1 upon 30 is 30 minutes. So option A is correct. Is that fine? Next problem. Pipe A can fill the tank in 4 hours. Pipe B can fill it in 6 hours. Both are open together, but A is turned off after 2 hours. How long will B take to fill the remaining part? Similar question we have just done. So let's get started with this one. So filling rate is given. Filling rate of pipe A. How long pipe A will take to fill the tank? It is 4 hours, no? So rate will be 1 upon 4. Similarly, filling rate of pipe B. How long pipe B will take to fill the tank? 6 hours. So filling rate will be 1 upon 6. Now combined filling rate. Combined filling rate means if both are working together, what would be the rate? Combined filling rate is add them up 1 upon 4 plus 1 upon 6 because both are doing the same work. Both are contributing in the work which we are interested in. Again, take LCM 4 and 6. I'll start with 2. It is 3 into 1, 3 as it is, 3, 1 and 1. So LCM is 2 into 2 into 3. 2 into 2, 4. 4 into 3 is 12. So LCM is 12. 4 3s are 12. 6 2s are 12. So it is 5, 5 upon 12. So combined filling rate is 5 upon 12, right? So now, so see, it is given that if both are open together for 2 hours. So after 2 hours, A is turned off. So work done in 2 hours is equal to 2 into combined rate, that is 5 upon 12, and that is equal to 5 upon 6. So work done in 2 hours is 5 upon 6. What is remaining? Remaining work is equal to 1 upon what has already been done, 5 upon 6, and that is 6 minus 5 upon 6 and 1 upon 6. So 1 upon 6 work, this work, 1 upon 6th of the work, you want to know how much time pipe B will take to finish, right? So again, suppose pipe B will take X hours to fill remaining 1 upon 6th of the tank. So while solving the problem during the exam, you don't need to write this everything out. You just write rate, combined rate, do the multiplication, get this work done, get this how much work has been done, and then subtract and do the basic things you have to do. You don't need to write this all these things. I'm doing it because so that you can understand it better. So X into what is the filling rate of pipe B? It is 1 upon 6. 1 upon 6 is equal to how much remaining part? It will, how much remaining part? It is 1 upon 6 again. So it is X is equal to 6 upon 6, that is 1. So it will take only 1 hour. So option A is correct. Is that okay? Next problem. Two inlet pipes can fill a tank in 12 minutes and 15 minutes respectively. How long will they take to fill the tank if opened together? So two pipes are given. One will fill the tank in 12 minutes, other can fill the tank in 15 minutes. So how long they will take if opened together? Simple. Compute the separate rate, combine the compute the combined filling rate, and time taken is equal to 1 upon rate. So filling rate of first pipe. How long it will take? 12 minutes. Na? So filling rate will be 1 upon 12. Similarly, filling rate of second pipe. It is 1 upon 15 because second pipe will take 15 minutes to fill the tank. Now combined filling rate, because both are working together, no? Combined filling rate will be, add them up. Again, you have to take LCM. 12 and 15. I'll start with 3. It's 4. It's 5. 2. It is 2. 5 as it is. Again 2. 1. 5 as it is. 5. It is 1 and 1 done. LCM will be 3 into 2 into 2 into 5. So 3 into 2 is 6. 6 into 2 is 12. 12 into 5 is 60. So LCM is 60. 12 5s are 60, right? 15 4s are 60. So it is 9 upon, let me write in next line. It is 9 upon 60. So total time taken is equal to 1 upon the rate. So rate is 9 upon 60. So time taken will be 60 upon 9. So 3 is 20. So 20 upon 3. Again, you have to do this division, basic division. So 23. 6 times it is 18. 2 is remaining. Point, add 0. 0 to 6. Again 18. 2. It will keep on going. It will take 6.67 around these many minutes. So option A is correct. Is that okay? So combined rate you have to compute and total time taken in filling the tank when both are working together will be 1 upon rate, because I told you time is 1 upon rate and rate is 1 upon time. Next problem. A pipe can fill a tank in 10 hours, but due to a leak in the tank, it takes 12.5 hours to fill the tank. How long will the leak take to empty the full tank? If it is not clear what they are asking, read the problem again. Okay, so a pipe can fill the tank in 10 hours. So there is a pipe which can fill the tank in 10 hours. Due to a leak in the tank, it takes 12.5 hours. How long will the leak take to empty that full tank? So they want to know time taken by leak to empty the tank. So time, how would you compute time? If you get to know emptying rate of the leak. If you get to know emptying rate of the leak, you will get to know the time, right? So how will you get to know the emptying rate? So see, filling rate is given. It is right. We can compute the filling rate. Let's start with that one. Filling rate is equal to 1 upon 10. But effective filling rate means how long actually pipe took to fill the tank. It is 12.5. So it is 1 upon 12.5. Can I write this 12.5 as 2 upon 24? Both are equivalent, right? Not 12.24, it is 12.25. So I'm multiplying numerator and denominator by 2. So it will give you 2 upon 25. So this is the effective filling rate. So now how long will that leak take to empty the full tank? So let's assume, so now see what we want to know, how long will the leak take to empty the full tank, right? So suppose leak will take X hours to empty the tank. Okay, so what would be the rate? So emptying rate will be 1 upon X, right? That is the emptying rate. Now effective filling rate is 2 upon 25. But effectively, what would be, means actually, if emptying rate is 1 upon X and actual filling rate is 1 upon 10. So combined filling rate will equal to 1 upon 10 filling rate minus emptying rate, that is 1 upon X. So this is the effective or combined filling rate. But it is given to be 2 upon 25, right? That is what is given. Effective filling rate is 2 upon 25. Now, from this equation, we have to compute the value of X. So, from this equation, can I write 1 upon X is equal to 1 upon 10 minus 2 upon 25. Again, we have to take LCM 10 and 25. Let me start with 5. 2 is 5. Again, 2 will be 1. 5 as it is. Then 5, 1 and 1. So LCM is 5 into 2 into 5. That is equal to 5 into 2 is 10. 10 into 5 is 50. So LCM is 50. Now 10 5s are 50. 25 2s are 50. So that is 2 into 2. So it is 1 upon 50. So 1 upon X is equal to 1 upon 50. So X is equal to 50. So 50 hours. So leak will take 50 hours to empty the tank. So option A is correct. Is that fine? Next problem. A piston is normally filled in 8 hours, but take 2 hours longer due to a leak. How long will the leak take to empty the piston if it were full? So exactly same question, just that we have changed the numbers. So filling rate is given, effective filling rate is given. We can compute. So let's get started. Filling rate is how much time? Uh, uh, so a piston normally filled in 8 hours. So filling rate of piston is 1 upon 8. What is effective filling rate? Due to leak, it is due to leak. What is the effective filling rate? Because it is taking 2 hours longer. So effective filling rate is 1 upon 10, right? Now, how long will that leak take to empty the piston if it were full? So suppose leak will take X hours to empty the piston. So combined filling rate or effective filling rate will be equal to filling rate, that is 1 upon 8, and minus emptying rate, that is 1 upon X. But combined filling rate is given to be 1 upon 10. So you have to solve this problem to get the value of X. So using this equation, we can write 1 upon X is equal to 1 upon 8 minus 1 upon 10. Then again you have to take the LCM. 8 and 10. I'll start with 2. 4 is 5. Again 2. It becomes 2. 5 as it is. Then 2. 1 and 5. Then 5 is 1 and 1. So LCM is 2 into 2 into 2 into 5. 2 into 2, 4. 4 into 2, 8. 8 into 5 is 40. So LCM is 40. So 8 2s are 40 and 10. Here 8 5s are 40, not 2s are. 8 5s are 40 and 10 4s are 40. So it is 1 upon 40, right? So 1 upon x is equal to 1 upon 40. So x is equal to 40 hours. So that is what we have supposed now. So suppose leak will take x hour. What is the value of x? It is 40 hours. So option B is correct. Is that okay? Next. So there are some practice problem so that you can practice. So these problems are based on similar problems which we have done. So if anything is not clear and if you get stuck on any problem, you just go through the lecture again. So everything will be clear. So let's get, so the first problem, what is given? Pipe A, B can fill the tank in 20 and, so pipe A and B can fill a tank in 20 and 30 minutes, right? Respectively. Pipe C can fill it in 15 minutes. If all three pipes are opened together, how many minutes it will take? So three pipes are given, individual, it is given how much time they will take. So you can calculate the combined filling rate. So here instead of two pipes, three pipes are given. So you have to add the individual rate. So 1 upon 20 plus 1 upon 30 plus 1 upon 15. Take LCM and then how much time? So time is equal to 1 upon rate. So this is the combined rate. Time you will get to know by doing 1 upon the rate. Two pipes can fill the cistern in 10 and 12 minutes respectively. A waste pipe can empty it in 15 minutes. If all three are opened together, in how many minutes will the cistern be filled? So this is the scenario. Here is your cistern. Two pipes, A and B, maybe filling the cistern, and here is a waste pipe which is emptying the cistern. So combined filling rate will be is equal to two pipes are contributing in filling the tank. So it is 1 upon 10 plus 1 upon 12. Both you have to add. But third one, waste pipe is emptying it. So rate of emptying is 1 upon 15. So this is the combined rate. Compute the rate and time is equal to 1 upon rate. Next problem. Pipe A can fill a tank in 20 minutes. Pipe B can fill the tank in 30 minutes. If both are opened together and after 5 minutes A is turned off, how much longer will be take to fill the tank? We have done a similar type of problem. So A and B both are filling the tank, but after 5 minutes, so you have to compute work done in 5 minutes and then you have to compute what is remaining and just assume that B will take X minutes to fill the remaining tank and follow. Next problem. A pipe fills a tank in 5 minutes. Oh, sorry, 5 hours. Due to a leak at the bottom, it takes 6 hours. If the tank is full, how long will the leak take to empty the tank? So basically, you have to assume that leak will take X hours. So similar portion we have just solved. Two problems we have solved. So filling rate is 1 upon 5. Effective filling rate is 1 upon 6 because due to leak it has taken 6 hours instead of 5 hours. And then you follow. Next, a tap can fill a tank in 16 minutes, another in 24 minutes. So there are two taps. One can fill in 16 minutes, another can fill in 24 minutes. Both taps are opened together, but after 4 minutes, the first tap is turned off. How much longer will the second tap take to fill the tank? Similar problem. So combined filling rate you have to compute. Then in 4 minutes, how much work has done? Then you have to compute remaining work and then assume that second tap will take X minutes, and so on. So I hope all problems are clear. If you face any difficulty, any doubt, first thing you have to do is you have to go through the lecture again. So I hope you enjoyed the lecture.